All right, we're going to go ahead and today and look at factoring trinomials. We're looking at trinomials in the form ax squared plus bx plus c. So the way that I'm going to factor these is I'm going to go ahead and use what I like to call the kind of reverse box method. And so when I teach multiplying polynomials, I do reference FOIL when we're talking about binomials times binomials, but I also like to use the box method just because it keeps it organized, really nice and neat and organized. And when we're factoring things, especially when A is not 1, we can actually use that box method in reverse and just factor out GCF, and it saves us a lot of time with guessing and checking. You might see people teach factoring, especially when A is not 1, a variety of different ways. In fact, I've taught it a variety of different ways. I found this to be the most effective way because it relates, our greatest factoring out our greatest common factor. And then it kind of saves us time because we're not doing a lot of guessing and checking. As long as we can figure out our 2 factors from the start, then we just use our GCF and we can factor it nice and simple. So the first thing that we're going to do is we're going to find the A, B, and C. And so again, we're looking at that form, ax squared plus bx plus c. And so A is always going to be my coefficient on my x squared term. So in this case, 2. B is always my coefficient on my x term. And C is always my constant. Next, we're going to go ahead and create a table. On the left-hand side of my table, I'm going to write A times C. And so A is 2, C is 3, so A times C is 6. And then on my right-hand column, I'm going to write just B, which is 5. And so what I need to figure out in this table to fill this table out properly is what multiplies together to get 6, and those exact same numbers also add up to 5. Again, you'll see people teach this different. The reason that I like and stick with my method of writing this out as a table is because maybe you have harder numbers to factor where there's a lot more factors and a lot more options. And so, hey, I get the answer wrong. I'm not sure what it is. And so then I can write down all of the possibilities I've already tried and didn't work. And so I'm not going back and trying those same options again. I move on to a new option. 6, there's only so many factors of 6. And so in this case, we're going to do, 2 times 3 is equal to 6. And then 2 plus 3 does not equal 6, it equals 5, which is what we wanted it to equal. So 2 numbers multiply to get 6, and those exact same numbers add up to 5, and that's what we want. So we're going to go ahead and again use that kind of what I call like to call a reverse box method. We're going to fill out the inside of the box, and then we're going to use that information and our knowledge of finding the greatest common factor to go ahead and find out what our factors are going to be. This first box always has the first term, so 2x squared. My last box always has my last term, which is 3. The other 2 boxes, we're going to take this 5x and we're going to split it into our 2 factors that we found, which is 2 and 3. So I'm going to write 2x and 3x. It doesn't matter. We could flip-flop the 2x and the 3x, and ours might look a little different when we actually write what we actually write on the sides, but our factors should be exactly the same. Once we fill out the box, we want to find, I like to start with the left-hand side. What's the greatest common factor between 2x squared and 2x? Well, the greatest common factor, they both have a 2 in common. They both have an x in common. Going to move down to the next one. What's in common between 3x and 3? Well, the greatest thing that they have in common is a 3. Now we need to go up here. What times 2x is going to get me this 2x squared? Well, it already has the 2. It already has one of the x's. I just need to get that x squared. Well, x times x is x squared. Now let's check. X times 3 does in fact get us 3x, so it works for that box as well. 2x times what is 2x? Well, they're already exactly the same, so to multiply something and get the exact same product, we multiply it times 1. And then if we check 1 times 3 also gets us 3, and so it works. So our factors are 2x plus 3. That comes from this left side here. And then our other factor is x plus 1, which comes from up here. And that's our answer. That is the factored version of our polynomial 2x squared plus 5x plus 3. We could also write it as x plus 1 times 2x plus 3. That would be acceptable as well. It's the exact same thing. It's kind of however you end up setting it up. If I were to switch this 2x and this 3x, that might change it. So where I write it like this, maybe you just write the top out first and the side out second. That's fine. Again, either of these answers would be considered correct solutions or correct ways to factor that polynomial. So let's try it again. Identify the a, b, c. So again, it's ax squared plus bx plus c. So a is 5, b is negative 17, and c is 6. Okay, so in the left-hand column, again, it's a times c, so 5 times 6, which is 30. And the right-hand column is b, which is negative 17. Okay, so if you think we have to multiply to a positive and add up to a negative, the only way to do that is if my two factors are both negative. So I'm going to have a negative times a negative equals a positive, and a negative plus a negative is going to equal a larger negative. On this one, when I was setting up to prepare for this lesson, it took me a while to figure out. I was thinking, okay, well, I know negative 6 times negative 5 equals 30, but negative 6 plus negative 5, that's negative 11, so that's not going to work. I was like, okay, well, what else do I know? Well, I know negative 2 times negative 10, negative 3 times negative 10 gets me positive 30. But negative 3 plus negative 10, well, that's negative 13. That's not going to work either. And I was sitting here and I was saying, what are other factors of 30? Well, negative 2 times negative 15 equals positive 30. And negative 2 plus negative 15 equals negative 17. And that works. This exact example is the reason that I like to make a table, because if I didn't write this down, and maybe you remember things better than I do, but if I didn't write this down, I'd keep going back. Okay, well, I know 6 times, no, that doesn't work. Okay, 3 times 10, I'm not sure, let's check. Or if I write them down, I already see, hey, these don't work. I already wrote them down as non-viable solutions, and so let's try something else. Okay, well, if this doesn't work, let's try something else. And I have all the options I've tried. I'm not going back and redoing those same factors again and again. If you get it on the first try, like we did on problem 1, that's totally fine as well. Okay, sometimes you might get it on the first try. Sometimes it may take you a couple tries to figure out the correct factor that satisfies both columns. And then it might just take you a little longer one time or another time, but we'll all eventually get there. Okay, so I'm going to go ahead and do that reverse box. In that first box is always my first term, 5x squared. Last box is always my last term. And then I take this negative 17 and I split it up into my two terms. So I have negative 2x and negative 15x. Greatest common factor between 5x squared and negative 2x. Well, they don't have a coefficient in common, but they both have an x. Between negative 15x and 6, well, they don't have a variable in common, but they both have a negative 3. You might ask, hey, well, when do I know to pull out a negative? I always like to pull out the negative when the first column is negative. You could pull it out when the second column is negative, but I like to kind of stick to one method and one way of doing it. So anytime I have this first column here, anytime this column has something that's negative, I pull out a negative, and that's just a habit. That's just normally what I do. Again, you could kind of switch it up, and that's fine. You should end up with the same factors either way. Now I need to figure out what I need to multiply by these rows to get what's in the boxes. So to get 5x squared, I need to multiply x by 5x. And 5x times negative 3 gets me negative 15. So that's positive, or that's a good sign. X times negative 2 gets me negative 2x, and negative 2 times negative 3 gets me 6. So my factors then, it's going to be x minus 3 times the quantity of 5x minus 2. And that's the factored form of that polynomial. Okay, let's go ahead and try another one. Okay, I'm not going to write out my formula here every time. It's actually on the left-hand side if you want to look at the slides. So A is 6, B is negative 5, and C is negative 4. So when I make my table, A times C, 6 times negative 4 is negative 24, and B is negative 5. So my factors here are going to be negative 8 times positive 3, gets me negative 24. Negative 8 plus 3 is negative 5. Okay, go ahead and draw my box. First box is always the first term, 6x squared. Last box, always my last term is negative 4. And this middle term here always gets split up into whatever my factors I found out in my table were. So negative 8x and positive 3x. Okay, what's in common between 6 and 8? Well, they both have a 2 in common, and they both have an x in common. Between 3x and negative 4, they don't actually have anything in common, so we're just going to put a 1 out here. What times 2 is going to get me 6? Well, that's 3. X times x gets me the x squared. 3x times 1 is 3x. What times 2 is going to get me negative 8? Negative 4. And then x times, well, there's no x up here, and so we just carry that x over. That works. Perfect. And then negative 4 times 1 is negative 4. Perfect. It satisfies all 4 boxes, so my factor, 2x plus 1, 3x minus 4, and we're done. Okay, moving on to the next example. A is 12, B is 11, C is negative 5. Okay, so I'm going to go ahead and make my table here. The left-hand side is A times C. 12 times negative 5 is negative 60. And then B is 11. So what two things multiply to negative 60 and add up to 11? Well, let's think a couple ways. Let's say we can do negative 6 times positive 10. Gets me negative 60. Negative 6 plus 10 is going to add up to 4. So that's not going to work. Okay, but what is going to work is we can say 15 times negative 4 gets me negative 60. 15 plus negative 4 equals 11. All right, so I'm going to go ahead and make my box. My first box goes my first term, 12x squared. My last box is my last term. And then I take this 11 here, and I'm going to split it into my 2 factors here. So I'm going to have 15x and negative 4x. So 15 and 12, they have a GCF of 3, and they both have an x. 4 and 5 don't have a GCF, or their greatest common factor is 1. Only one of them has a variable. I'm going to pull out a negative 1. Remember, I like to stick to the rule. If I have a negative in this column here, I like to pull out the negative first. So 3 times 4 is going to get me 12. I'm going to need another x. 4x times negative 1 gets me the negative 4x. 3 times 5 is 12. I don't need any more x's. And then 5 times negative 1 is negative 5. So it works for all 4 boxes. My factors then is 3x minus 1, 4x plus 5. And there we go. Okay, a couple more examples here. So again, A is 3, B is negative 11, C is 10. Make my table. Left-hand column, A times C. 3 times 10 is 30. B is negative 11. Okay, so to multiply to multiply to a positive and add up to a negative, I'm going to have a negative times a negative. So we can have negative 6 times negative 5 equals positive 30. Negative 6 plus negative 5 equals negative 11. So that works. We're going to go ahead and create our box so we can work in reverse. First box is always our first term. Last box is always our last term. And then this middle term always gets split into our two factors. So we have negative 6x and negative 5x. So in common between 3 and 6, they both have a 3 in common, and they both also have an x. Negative 5 and 10, they have a negative 5 in common. They don't have any variable in common. Okay, what times 3 is 3? Well, that's just 1. X times x is going to get me x squared. X times negative 5 gets me that negative 5x I need. 3 times negative 2 is going to get me negative 6. X I already have. Let's check. Negative 5 times negative 2 is positive 10, so it works for that last box as well. My factors are therefore 3x minus 5, x minus 2. Okay. Next problem. A is 8. B is negative 10. C is 3. So let's make a column. A times C. 8 times 3 is 24. B is negative 10. So remember, to multiply to a positive and add up to a negative, we're going to have a negative times a negative. And so we have negative 6 times negative 4 multiplies to positive 24. Negative 6 plus negative 4 equals negative 10, so that works. Let's make our box. First box is our first term. Last box is our last term. And then again, this middle term gets split up into our two terms that we found, or two factors we found down here. So I'm going to say, okay, well, negative 4x and negative 6x. Okay, in common between 8 and 4 is 4, and they both also have an x. Between 6 and 3, I'm going to write negative 3. Again, sticking to that, if there's a negative in the left column, I'm pulling it out. Otherwise, I'm waiting till later. 4 times 2 is 8, and then I have another x on there. 2x times negative 3 gets me that negative 6x, which I needed. Perfect. 4 times, well, negative 1, and then x is already there. Negative 1 times negative 3 gets me positive 3. So perfect. My factors are 4x minus 3 and 2x minus 1. There we go. All right, last two examples. We're going to have a GCF. Now, normally I'm not going to always tell you, hey, you have a GCF, make sure to look for it. Anytime you're doing problems, it's a great habit to get into to make sure you're checking to see if you have a GCF. So we do have a GCF in here. They're not all divisible by 10, but they are all divisible by 5. So we're going to pull out a 5. 5 times 2 is 10, x squared. 5 times 15 gets me 75. And 5 times 7 gets me 35. For on my squared here, on my x, on my 2. Then we're going to pull this out. It's going to come down into our final answer, but while we're factoring, we're only looking at this particular polynomial. And so when I'm identifying A, it's just 2. B is 15. And C is 7. So make my table. Left-hand column is A times C, so 2 times 7, which gives me 14. b is 15. And so to multiply to 14 and add up to 15, well, 14 times 1 is 14. And 14 plus 1 is 15. Don't forget about something times 1, or itself times 1. I feel like that factor is often forgot about, but it is absolutely usable. In that first column, or that first box goes my first term, 2x squared. Last box goes my last term, which is 7. Then remember, I take that middle term and I split it into the two factors that I found. So 14x and 1x. Between 2 and 14, my GCF is 2. They both also have an x in common. 1x and 7, they have no GCF other than 1. 2 times 1 is 2. X times x gets me x squared. X times 1 gets me that 1x. 2 times 7 is 14. I already have the x, so I don't need to add another one. 7 times 1 is 7. So that works for all of the boxes. Don't forget to bring down my original GCF down, which is 5. And then I have 2x plus 1, x plus 7. And that's my factored form. Okay, last one. There is a 2 in common between all of these terms. I can factor that out. I'm left with 6x squared plus x minus 1. So a is 6, b is 1, and c is negative 1. Make my table. A times c. 6 times negative 1 is negative 6. b is 1. So what multiplies to negative 6 and adds up to 1? Well, 3 times negative 2 equals negative 6. 3 plus negative 2 equals positive 1. So again, make my box. First box is my first term, 6x squared. Last box is my last term, which is negative 1. And then I break down this middle term into the 2 that I found here. So 3x and negative 2x. Okay, GCF between 6 and 3 is 3. They both also have an x in common. Between negative 2 and 1, my GCF is negative 1. 3 times 2 is 6, and I need x squared, so I need that x times x. 2x times negative 1 is negative 2x, so that works. 3x, well, those are exactly the same, so all I need to do is multiply it times 1. 1 times negative 1 gets me negative 1. Perfect, all 4 boxes work. Don't forget to pull down this 2 here. So 2, and then we have 3x minus 1, 2x plus 1. And that's how we factor trinomials.